Crystal lattices. Let us now understand crystal lattices. The main characteristic of crystalline solids is a regular and repeating pattern of constituent particles. A regular three-dimensional arrangement of points in space is called a crystal lattice. Bravais lattices. There are only 14 possible three-dimensional lattices. These are called Bravais lattices. The following are the characteristics of a crystal lattice. The first one is each point in a lattice is called lattice point or lattice site. The second point is each point in a crystal lattice represents one constituent particle which may be an atom, a molecule, or an ion. Unit cells. Unit cell is the smallest portion of a crystal lattice which, when repeated in different directions, generates the entire lattice. A unit cell is characterized by its dimensions along the three edges A, B, and C. These edges may or may not be mutually perpendicular. Angle between the edges, that is alpha, beta, and gamma, where alpha is the angle between B and C and beta is the angle between A and C, and also gamma is the angle between A and B. Thus, a unit cell is characterized by 6 parameters A, B, C, alpha, beta, and gamma. Primitive and centered unit cells. Unit cells can be broadly divided into two categories, primitive and centered unit cells. Click on the corresponding buttons to learn more. Primitive unit cells. When constituent particles are present only on the corner positions of a unit cell, it is called as primitive unit cell. There are 7 types of primitive unit cell. The first one is cubic unit cell. The 3 cubic lattices have all sides of same length and angle between all faces is 90 degree. The 3 cubic lattices are primitive, body-centered, and face-centered. Centered unit cells. Centered unit cells are of 3 types. The first one is body-centered unit cells. Such a unit cell contains one constituent particle, that is, atom, molecule, or ion, at its body center besides the one that at its corner.